topic. I'll get my chat set up for you guys here. And I want to adjust out my camera a bit. It's good to have you guys in here on this Saturday. Make sure you guys can see the board behind me. So as you guys filter in, let me know if you guys can read the board behind me. If it's too hard to read, then I'm going to readjust. I am noticing that it is backwards. So let me set you guys up the other way here. There we go. All right. Just checking positioning and everything. I want to make sure I'm good for you guys. Today is going to be a rather big topic. So we're going to get into quite a bit going on here. Because of how I have to turn you guys, I'm not going to be able to read chats. So you guys are going to see me kind of switch positions and kind of go back in, back and forth in the camera in order to see kind of what's going on. Yeah, live is just not trying to make sure everything's set up and everything's doing good. All right. So let me start with today's announcements, guys. Thank you guys so much for all your support. Continue hitting the like button, the subscribe buttons, ringing that notification bell so you get notified when we go live. We do this every Saturday at 1 p.m. Central. Today's topic is going to be on, that's right, stop chasing trouble codes. Why is chasing trouble codes such a problem? Well, here's the thing. The modern computer systems in cars have a lot of different systems attached to them. Today, we're going to cover some of those systems and how they communicate with each other and why just chasing a code isn't necessarily going to yield in the result that you want. So in order for us to diagnose this and look at this, we're going to break down a real world example that happened on Malibu steel. I'm also going to take that air cleaner off on that car a little bit later in this video. You guys will be able to see exactly where those parts were and you'll understand what I'm talking about, but we're going to rely on our trusty board here first. And it's important for us to do the board step so that you guys understand how this computer works with the entire system on an engine and why one piece not working necessarily doesn't mean that that's the problem. So let me check chats. Henry says hi. Hi, Henry. Good to have you in here. Let me make sure the internet's working good. If I don't have a good solid connection, sometimes it causes problems. Okay. It's showing connected. All right. So we're going to continue talking about our topic here of chasing engine codes. Let me give you the example that I ran into with Malibu steel. First of all, let me clear the board here. And I'm going to explain the first code that came up. This code right here. This P0106 is a very common map sensor code. In order for us to figure out what's going on with this, we need to know what that code is trying to tell us. And the thing is it could tell you that there's a bad sensor. It could also tell you that something else is wrong in the system, causing that sensor to get a bad reading. So we're going to break down the components and how they work together. so that we can understand how this code comes about so that we know how to fix it properly. In this process, you're going to realize that sometimes you do buy an extra part that you may or may not need. And in order to diagnose this, because you may not have a very advanced scan tool for your OBD-II, which is your computer system. So when they say OBD-II, this is your on-board diagnostic, meaning that you want to know what's going on with that car. So you're going to scan the OBD-II port, which is usually on a GM located underneath the front driver steering column. There'll be a serial port that you plug in a computer that allows you to scan the codes. Let me just check for chats, guys. I know I got to kind of go back and forth looking at chats. So if you guys do get something and you want to chat it in, I'll look at it when I can and then try to answer your questions as we go. But I wanted to break down the basics. I scanned the OBD-II, it came up with this code. Now, let's break down the components of that system. And this is where it can get sticky for a lot of people, because we're going to start with our main computer right here. This is our computer that has wires that come out of it. Okay? Computer is usually your central piece. This is what everything piggybacks off of. This is where the information is gathered, stored, and then diagnostic changes will be made based on what information is given to it. You'll also have a throttle pedal over here, but we don't really worry about that throttle pedal here until later in this video. But the throttle pedal does play into the throttle body, which we do have to cover in this particular setup. Is the code that we got does tie into the throttle body. It's going to take us a bit to get there, but we will. So, with our computer here, what we need to look at is the components of the system. One component is the air box itself. So this is where our filter is. And this is where the air comes into the system. It's the only way air should be coming in, because outside here, there is a sensor that goes into our tube. Okay, this goes into the tube for the airflow coming in. This is your mass airflow sensor, or as we call it, MAF sensor. This reads how much air is coming in. This is your first piece of the puzzle. So you have your computer, then you have your first line sensor. This is your first line sensor. This gives information to the computer. I'm going to cover that in just a bit. I'm also going to cover the wiring so that you guys know how this connects. If you guys want, through this process, I will give you guys examples of things I've done in the past with cars that allow me to do tuning and allowed me to get into the tuning world and understand these systems. But you guys got to get the likes up for me to do that. So make sure you guys are hitting the like button when you're in here. Let me check chats. I know I got to keep flopping back and forth because I don't have a screen in front of me. The Reverie says hi. Hi, good to have you in here on this Saturday. Guys, we do this every Saturday at 1 p.m. Different topic. This one, we're doing the diagnostics on the code that we found. We're looking at the problem. If we get enough likes and we do really good with this in the beginning stages here, we get good interaction, then I will break down the throttle body. I will actually take the throttle body apart right here in this video for you guys. But we got to get the likes up and we got to stay, doing good with the viewership. Guys, the more likes we get, the more people will show up for the live. That's how this works. So, all right. So as we go here, we have the MAF sensor. Then we come down to what is known as our throttle body. So here would be our throttle body. Inside here is our butterfly valve. More importantly, there's a sensor with a connector on it. Okay? That connector is going to have a bunch of wires. We're going to cover wires here in just a little bit. I want to cover all the components first. Then we're going to look at how the wiring links to the computer. Lastly, we'll talk about how these all work together. So after this, we'll have another piece in this puzzle, and this is on the intake side of things. So you have the intake here that this is bolted to, and the intake will also have another sensor in it. This sensor plugs into the intake. It also has a connector on it on top as well. That connector has wires in it, but that sensor right there, throttle body down here so you guys can understand. Engine intake. This sensor right here, this is the one that throws this P0106. This is a map sensor. So, map sensor is, what it does is gauges the absolute manifold pressure. This tells you exactly what's going on inside the intake. If you're pulling air and it's getting past the throttle body and past this sensor, and you're getting too much air or not enough air, this will throw a code. That code that you get is usually this one up here, but it can also be tied to a P0107 and a P0108. The reason I'm doing this on this board for you guys, so that you guys understand, I have this already memorized in my head. I didn't have somebody come in and do this for me. I know these systems very well, because if you're going to do anything with tuning, you need to understand how the entire system works together and how it's designed to work. As we break some of these components down later on in this video, I'm going to explain the throttle body lag on GM vehicles. And for everyone who is frustrated by that problem, you're definitely going to want to stick around for that. Let's see what we got for chats. Okay. All right, kind of a lower view day, but we'll do the best we can here with this. All right, so next we've got some major components in here. So we've got our MAF sensor, which gauges our incoming air. We have our throttle body that has our sensor on the side of it, which also has our stepper motors, which I will cover later. And it also has our MAP sensor. So these systems work to gauge the amount of air coming into the engine. What the computer needs to make a car run right and run it safe without having damage done to the engine is it needs information on air to adjust fuel. Okay? If you guys can't see that, I'm going to bring you in close so you guys can. Yeah, you guys can read that pretty good. Okay, so what it's doing is it's taking information related to how much air is coming into the system to adjust the fuel that it needs to maintain the stoichiometric rate. That stoichiometric rate is 14. I always miss the smaller amounts. I want to say 14.7 is the number that comes to head. If my mods are in here, my wrench squad, you guys know who you are. Make sure you guys chat in down below. They can look up what that point number is for me. I'm pretty sure it's 14.7 is the stoichiometric. It might be 14.5, might be 14.3, but I'm pretty sure it's 14.7. So when it's taking air in, it's trying to maintain this rate. So even as you accelerate under harder throttle, it's trying to maintain that stoichiometric rate. What that means is that when that air and fuel is mixed and then injected into the top of the cylinder head and it combusts inside the combustion chamber, it wants that to be the perfect number for air to fuel, or some people call this air to fuel ratio. So some people call this air to fuel. Okay, check. All right, guys, give me a thumbs up if you guys are understanding the components here right now. I want to make sure you guys have a good understanding of what's here before we start diving into the rest of this. Okay. All right. I don't see anything that says that you guys don't understand what's going on, so we're going to go ahead and continue diving into this topic a little bit more. So what happens is once we have our sensor here, we have wires, and I'm going to color these wires differently so that we understand what these wires mean. So we're going to have a hot wire that's going to come in to our sensor. Now the hot wire might go to the computer, or it might go to a battery. But in order to go to the battery, it's going to go through a bunch of relays. We're not going to draw those relays because that can get really confusing. Just know that usually you're going to have one wire that comes off as a power wire. Sometimes the power is being fed to this, and then it relays a signal. That signal is going to come out of the sensor. That signal will go to the computer. That signal wire tells the computer how much airflow is coming in. As it comes in, it's going to take this amount of air coming in, and with the injectors, it's going to spray the right amount of fuel in. Now, as your throttle body opens, though, you're going to be allowing more airflow in. The more airflow is going to also throw more air in through the sensor, which then will allow it to adjust. Do you guys follow this so far? Okay, so if you guys are understanding this process right here, let's go ahead and dive into our throttle body and our map. Again, we're going to have a signal wire that comes off of our map sensor as well. So we're going to have a signal wire that comes up here. We're also going to have a signal wire that comes from here up to the computer. We're also going to have a signal wire coming from our throttle pedal to our throttle body. This system here is where we're getting the GM legs. So in order to fix this, we will have to rely on a separate system outside of our normal system that we have. I will talk about that a little bit later in the video. I'll also explain this throttle leg a little bit better. From here, we're also going to have a signal wire that's also going to come back down to the throttle body. Now, why would this come back down? And why does it look like there's a component missing in this? Because I've intentionally left that out. We're going to cover that system right now. And the reason I have to do it this way is so that you guys understand how this all works. This is very simple, rudimentary stuff. So all I'm doing is giving you guys the basics. Now, each automotive components are different from vehicle to vehicle. Just know that it's not always going to look like this. It's not always going to have this configuration. The wiring may be different, like its power sources might be different. Where it's getting its information from might be different. So like this one here, some of these, the map sensors also have a power wire. So some of these might have a power wire. This definitely has a power wire. This will go off to a fuse panel. So there'll be a fuse panel. This is going to get power from there. You probably have a power wire coming from your throttle body. Like I said, these are all just kind of rudimentary things that we're talking here. But before I dive into this throttle body, let me check chats again, guys. I know it's a little annoying for me to go back and forth, but hi, guys. It's good to have you in here. APM Auto, sorry, just getting tuned in. Good to have you in here, brother. Really good to have my mod squad in here. You guys really do help. The wrench squad is awesome, guys. I really do appreciate my wrench squad. So I'm going to give APM a little bit of time to take a look at this and kind of understand what's going on here. I want to get his take on what I've drawn so far. Just kind of get your thoughts on it. Doing some dryer repair today. Well, you could be doing that kind of repair. I was in the shop until 2:30 this morning. Whoa, man. Got to get some sleep sometime. All right, so APM, tell me what you kind of see there. Is that making sense to you as far as that drawing? Give APM a little bit of time here to diagnose this and kind of see what this is, kind of understand what's going on. This is all rudimentary stuff, guys. This is very basic, drawn out, how this system works. But we have to understand this in order to start figuring out how to diagnose trouble codes. So all right, what do we got? All right, so I'll keep rolling here. I'm sure APM will tune in here in just a bit. So let's go ahead and start talking about the throttle body itself. 9 times out of 10, your problems either start from here or are involved in this process, at least in GM vehicles. What happens is there are 2 components of this throttle body. There is the motor itself that runs the blade. And then there's the electronic side, or basically the electrical control. So I'll call it E-control for now. So the E-control does a few different things. It takes the information from the computer and then relays this to the motor to move this blade. All of this is done by the signal wire that comes from the throttle pedal that can either go straight to the throttle body or also goes down to the computer. And this is where we start getting the legs. Under a full throttle situation, you should have one signal wire that goes from the pedal to the throttle body. Not all systems are created that way, but some are. So especially in your high performance modes, a lot of times when you're getting that direct feed, it's throttle to blade, straight up, wide open. That only happens under a wide open setting. Otherwise, it sends all the information to the computer diagnoses what it wants and what it's going to do. As that blade is opened and more air is coming in, not only will it send a signal to the injectors, to increase the fuel, but it will also send that signal back down to the throttle body to adjust any minor changes that are being made to that pedal. So as you're driving and you're in traffic and speeding up, slowing down, speeding up, slowing down, it's all running through the computer. So it's throttle, computer, throttle body. That's the rudimentary of how that system does that. Let's see here. We got APM says computer ECU primary inputs. Yep, that's exactly what we're looking at. He also says depending on if it's an older style or not, older ones also have a slightly different variant, similar throttle body. My truck is actually originally was cable driven, but the engine swap was a drive-by-wire. Yes, correct. Guys, the reason this is so complicated and why APM brought that up is this is a drive-by-wire system. And the reason this adds so much more problems is because troubleshooting these, trying to figure out which one is not working, becomes a lot harder because you could get your code here, but your problem could be here in the E-control. This is why just chasing the code P0106 isn't necessarily going to give you the right part to replace, because that code is going to pull you to the map sensor. The map sensor is showing a fault. It doesn't mean that the sensor itself is faulty. It's saying that there's a fault within the system causing that map sensor to throw that code. This is why we can't just blindly throw parts at a problem. Now, here's one way that people use to diagnose things, especially if you don't have a very advanced scan tool. Let's say you had a super advanced scan tool. You could actually pull up the frequencies that this thing is sending a signal to the computer, and it can tell you if this map sensor is working properly. If you don't have a computer or a scan tool that works that well to be able to do that, then you need to do something else to diagnose what's going on here. Guys, give me some thumbs up if so far everything sounds good and you guys are understanding what's going on. We're getting a lot of engagement, guys. Please get those likes up. We're really trying to grow this channel this year. I really want my mods involved. They've been a great help to me so far. You guys, all of you guys help make this channel what it is. We're also going to try to bring you guys some merch later on this year. You guys are starting to see some of the merch that I'm wearing. But this only happens if we can get the engagement up, get the subscribers up, and get the likes up. We really do want to grow this, but we really do need your help. So, all right. Now that we've got this, let's talk about this E-control for a little bit. What does the E-control do? What is its functions? Number one, it runs that motor. Now, the motor could be called a stepper motor, which is not correct. I'm going to explain the whole stepper motor thing in a little bit. I'll do that when I erase this and I draw just the throttle body. I'll explain the stepper motor and what that really means. But it runs the motor. It also has a function of a throttle position sensor. Okay? Throttle position sensor is located in, most of them are located in the throttle bodies now on newer vehicles. They don't have a separate one because they tied everything into the connector related to the throttle body. It's a lot easier for them to control this one component, and when this goes bad, they can just unbolt this with 4 bolts, pull that out and replace it. And when you do that, you're going to get a brand new motor, a brand new throttle body, new blade, and you're going to get a new throttle position sensor. A lot of times the sensors will get damaged over time, meaning you'll get rough idle, you'll get poor idle, you'll get high idle when you shouldn't be. And I'll explain how this code came up in the Malibu. This came up because we were having a high idle situation, which threw our map sensor off. The reason that code all went down that way is because of what happened to the throttle body. Guys, we did a throttle body cleaning video on this channel already on Malibu steel. Now, I don't suggest going over there and watching that right now because you guys are going to miss the good content I'm giving you guys here. So we definitely want to stay focused on this. But after this video, if you guys would like, go check out that video of how I showed how to clean it. Now, not all the time of when you clean this throttle body, does this throttle body actually come clean and work. Sometimes this goes out, it goes bad. Sometimes the wiring has an issue or a glitch. Sometimes you get that chemical down inside that throttle body and it shorts out the electrical components. That's why I told you guys in that video, be very careful. Now, over time, the throttle position sensor does wear out, which is usually what does a lot of damage to these. The other thing that can tend to go bad is the motors or the bearings on this blade. And you can feel it when the bearings start going bad because I'll show you later. Let me check chats. All right, we got APM. Guys, make sure you guys chat in. I try to read all the chats. You guys don't have to super chat stuff in. I read them all on screen as I can get back to them. I wish I knew all of the P codes off the top of my head. More P codes for cars than 10 codes for fire. Yeah, there is a lot of P codes. Math is super delicate. Yes, guys, he just brought up a good point. This is very sensitive. When you guys do clean these and they do make a cleaner for cleaning those, give you guys just a bit here. I'm trying to make sure if I have a candidate, I'm going to show you guys. But if you guys are going to do anything car related and you need to clean that component, make sure you have the right stuff. Don't mess around with anything other than the right chemical for this because you can damage a lot of stuff. It might be out because I just did one here the other day and I may not have. There, I got it. It's hiding all the way in back. All right, guys. So let me check chats quick. I'll talk about the buildup in a little bit. APM. Okay, so the two chemicals you guys are going to want to need if you're cleaning out throttle bodies is you're going to need a throttle body cleaner, not a carb cleaner. A lot of people will just grab a can of carb cleaner, but you don't have carburetors on cars nowadays. The throttle bodies that come out now have a small coating on the inside of it. If you spray it with carburetor cleaner, it strips that chemical off, and the minute it does, it doesn't run right. You have to use a throttle body cleaner. Now, sometimes throttle bodies get so bad and so built up with carbon that when you go to clean them off, you wind up damaging that coating anyway, and the throttle body doesn't work right. Or you get the chemical down inside the sensor into the electrical components, and it shorts it out. This is why you should never start a throttle body that you've cleaned out until it's sat for 24 hours. This stuff will evaporate. If you rush the process, you're going to risk damaging the throttle body. The next one is the mass airflow sensor cleaner. So this is used to clean that sensor. You do not touch that sensor at all. This is the only thing that gets sprayed on that sensor. Don't wipe it, don't rub it, just spray it down, clean it the best you can, and let it air dry. Again, I would go 24 hours before hooking it back up in the car. Make sure that it is completely air dried before you hook it back up. Again, this stuff could short out the electrical components within the sensor, causing it to fail. All right, let's see what we got for chats, guys. I got a couple more here from APM. I had a 97 Grand Prix with a 3800 would freeze up throttle cable blade in the winter. Luckily cable driven. Yeah, on a deal like that, usually if that does start sticking on the cables, that usually means that water or something got in there, kind of froze the cable up. So usually I would look for cracks on those, but I'll cover cables here in just a bit. It would only freeze shut. Yeah, no, that's lucky. If you touch it, the math, just go buy a new one right away. LOL. Probably junk no matter what make. Yes, correct. If you accidentally touch this while cleaning it, just buy a new one. Don't even try to put it back in and salvage it, because the oil off of your hands sticks to the sensor itself and you can't wash it off. And unfortunately, it permanently damages that sensor to where it won't read right. That sensor is very delicate and does not take a lot to mess them up. On the throttle body, when we're cleaning them, again, we can damage them just based on how we're doing it. The only thing that I would tell you is that if it's a really old vehicle and you're gonna go ahead and clean it, just be prepared that you might have to buy one. Now, I've already bought a MAP sensor for Malibu steel, so I knew mine was okay. I can eliminate this out of it. Besides, this code comes up as a MAP sensor, not a MAP sensor. Two different sensors, both of them do different functions. This one is telling you what the manifold pressure is. If the manifold pressure isn't reading right according to your throttle position and your math, it throws a code right there. Guys, I've had to memorize a lot of these components in order to do anything related to tuning. So you have to understand all of this before you can even attempt to try to set an air-fuel ratio or set timing, because this is all related to timing. It's all the components tied together, and how you adjust that timing is based on how these components are working together. If you have one that isn't working properly, you can't tune it because you can't get an accurate reading. These readings from this sensor here need to be accurate. Sensors from this here, that must be accurate. Throttle position absolutely has to be accurate. If your throttle position sensor is not reading properly, all of these are going to read inaccurate. So this is usually where I point my first problems at. But because of the cost of a throttle body, it isn't the first thing I buy. Oftentimes, if the code is coming from here, from the math, I will try to clean that math up, put it back in and run it to see if that will fix any problems. On a map sensor, if the map sensor is less than $75, right here, less than $75. Okay? General rule of thumb, if that sensor is less than 75 and you don't have a scan tool that can give you all of the information here and you be able to see the signal outputs, if your scan tool doesn't give you signal outputs, then you would buy this sensor, put this in, and see if your idle gets better. If it doesn't, switch it back out and put the factory one back in it. Because sometimes the aftermarket sensors are not good sensors. So rather than creating more problems, you're using this as a test bed. You're testing to see if this code came up because that sensor had failed, because you can't read that signal input. That's the only time that you want to waste money buying a part. And you always pick your lowest cost part that's tied to the code. Meaning that if this is your code, this would be the part that you want to test. If you don't have a scan tool that can test that part to make sure that it's working properly, then you have to try testing it with a different one. Now, some people will buy a junkyard and they'll try to swap it that way, but oftentimes your used parts are already damaged. They're already wore out. If I was rebuilding a motor, which you guys are going to see later this year, I'm not putting used sensors on a motor, especially one that's already a used motor that we're buying from a salvage yard. I'm putting all new stuff in it because when I drop it in, I want the motor to be 100% fresh. I don't want to put used components in that could break and start causing me to chase trouble codes. This is what we're trying to avoid, is chasing the codes. This is the only time you buy a part to diagnose though, is when you're tying it directly to the code related that you have. If you put this in and it starts doing a bunch of weird things, high idle, won't idle down, rough idle, doesn't want to idle right, then you have no choice. You want to put the old sensor back in. Make sure you put the new seal on it though. Use this color for the seals, I guess. So make sure you put new seals in it. You don't want to put this back in with a used seal. It could give you a code or cause a fault. So on that, you definitely want to go with the new seal. Crazy story here. I have asked my dad what he tapped into, math or map, but we put a few homemade hydrogen generators in a Dodge Grand Caravan in the 90s. Had to start on gas, but we cut. Then he also says fuel we had in the van running about 30 miles per hour on hydrogen only. That's a pretty good setup. We had a variable resistor and a cutoff switch for the resistor and generators to turn the system off. Yeah, what APM is talking about is a very advanced system. What they were doing was they were using this gas system, then they were piggybacking another system onto this. That system allowed them to get better miles per gallon and probably allowed them to not have to spend so much in fuel, especially during the time that they were talking about. Fuel was really high. It's not as high today as it was back then, but we have seen times where fuel has been very high, meaning like almost $5 a gallon, if not closer to $7, depending on where you live. I know there was times in California they saw almost $12 a gallon fuel. That's ridiculous. And what it does is it actually chokes people and allows them to not be able to move or go anywhere because the fuel price is just too high. So now that we're breaking this down, we've kind of gone through some of our components and the main key parts. We talked about the sensors that are tied into our system. We also talked about some of our substantial other side components that are related to this system. Now it's story time. So I scanned Malibu steel. And when I scanned Malibu steel, it came up with this code. This code was my map sensor code. So after replacing the map sensor, I got a high idle and a rough idle. So high idle and rough idle. Okay. There's one more component that I haven't talked about that is tied to the 2.4 liter engines. The 2.4 liters have solenoids. Those solenoids are located on the cam. So if you have this here, you'll have your camshafts going through your block. Okay, you got your camshafts coming through the block here. Some are going to have about 4 cams, some will have 2. The common is 4 camshafts. This particular engine has 4, so it has 2 on the intake side, 2 on the exhaust side. And there's a sensor that goes down inside there. That sensor adjusts based on what the cam is giving it for information. So as the cams move up and down, it will send a signal. Let me grab the right pen here. I don't want to confuse us any more than what we already are. It will send signals to the computer. Okay. So these cam solenoids here send signal to the computer. And what those will do is they can also adjust idle based on where the cam is located and how fast it's moving. So it uses cam position, speed, and everything else to adjust. It also uses oil pressure to adjust if it's trying to go into fuel save mode. This is where we get into weeds and we can get lost. All that you need to know with these is if you're having a bad idle, don't be afraid to pull these out and actually look at them. Make sure that they don't have any metal buildup on them. Make sure that they're clean, and then you can just put those back in. If you find that there's metal shavings on these sensors because they do pull oil into them, you'll get metal shavings on the bottom. Again, newer engines, you don't deal with this on older engines. Let's see what you guys got going here. Without tapping into sensors, the hydrogen system actually makes the vehicle think it's lean, causing it to burn more fuel. The truth to why everyone fails at it. Correct, APM. Absolutely correct. So what happens is when people try to piggyback off of the system and try to put alternative fuels into it. We can talk about nitrous if you guys want. I can get into that topic. Guys, hit the like button though. If you guys really want me to dive into performance side of things from this system, make sure you guys are hitting that like button. Hit the subscribe button. It does really help the channel, and it helps us grow a lot so that we can get more information like this out. So what happens is the reason that he's saying that it goes lean is because you shut off the fuel side, you're using the alternative fuel, and because the alternative fuel may or may not have the same burn rate, it kind of messes with this entire system. And especially from this point inward, your airflow in isn't going to change very much. It's only going to pull as much as it wants to pull. Your information coming from your throttle body is going to remain roughly the same because it depends on what you're telling it from the throttle and what information it's getting from your MAF sensor, the amount of airflow into the engine. Where it gets sticky with the alternative fuels is when you try to run off of a different system. This computer doesn't necessarily know what system you installed in the vehicle, meaning that this isn't communicating with the rest of the engine. So it gives a lean and then it goes and starts doing a whole bunch of weird stuff. It can cause it to dump fuel as a measure to save the engine. This is a code that we see a lot when you're dealing with dyno situations, is when they've decided that they want to run an alternative fuel or they want to run something that's hotter, that burns hotter. What can happen is as the air comes in, gets past the throttle body, everything's reading good at this point. Everything's great. But once it gets into the manifold pressure may skyrocket. And the reason that it skyrockets is because of the amount of added pressure from the different fuel that you put in the vehicle. What can also mess this up, this MAP sensor, let's say you go in here and you start building and you start playing around in here. Let's say you bump the compression up. Let's say stock compression is 10.521. When it's that's what the computer's designed to run on. Let's say you go ahead and bump that up to 13.5. Now that you've bumped your compression ratio up so far, now your manifold pressure is also going to increase, meaning that this is going to throw this code because your manifold pressure is skyrocketing. The other way that this can happen, where this can start climbing and give you a high reading, let's say one of these got a piece of metal stuck up inside of it. If it gets a small little sliver of metal stuck up inside of this sensor, what it can do is give it a false reading of high manifold pressure, meaning that all of a sudden it's not getting the right amount of oil into that sensor, to be able to do the controls and the functions for the VVT, variable valve timing. When it doesn't get the right signal, it's going to start doing weird things from this sensor all the way back out, meaning that it's going to mess with the manifold pressure. It's going to mess with this sensor here. It could even mess with the throttle position. This is where a lot of people misdiagnose their vehicles. They misdiagnose it because what is actually a throttle position problem is caused by alternative things on the outside that they're not looking at. Either a high compression situation, if you built the engine, a faulty sensor or solenoid, because this is a solenoid, or the sensor. If you're dealing with bad things here, it can all have an effect right here. So much gets tied into this throttle position on the GM side of things that this is really where a lot of tuning needs to be done. And this is where GM has failed us for so long. Guys, make sure you're hitting that like button. I'm bringing you guys some fire content right now. Also backfire from the hydrogen, blow a plastic intake to pieces. So anything, so thinking about try it, be careful, hydrogen has no smell. Yeah, guys, normally under street use, I would never suggest running a hydrogen system. And not only is it harder to get the hydrogen, the actual hydrogen gas, but it's also a lot more difficult to make the system run properly. And a lot of cars nowadays don't need it. A lot of cars, if you put the right components in it, like good spark plugs, you put in new coils, you put all this stuff in it, most vehicles will average 27 to 31 miles to the gallon. It's not really needed to go with the hydrogen setup. And the amount of risk and danger you run to that system, the better chance you're going to have of blowing up the engine. So on that, I don't necessarily recommend it. Now in a race application, I can understand why people would want to go with alternative fuels because it generates more horsepower, which is what people are after. The only other thing is the hydrogen can give you a little bit of fuel savings, but really it doesn't if you're not able to shut down this computer setup and the VVT and all of this. If you can't shut this down while you're on hydrogen, then this system is going to fight you. And from a tuning aspect, that's the nightmare here, is when somebody wants to say, okay, we're going to run gasoline, but then at a certain point, I'm going to kick in nitrous. The nitrous adds so much more complexity to this situation because not only is it going to increase cylinder pressure, once it has increased the cylinder pressure, it's going to increase intake manifold pressure, meaning this sensor is going to be off. You need to understand that when this all kicks in and you're trying to run a stock computer, not an aftermarket computer, it will not understand the nitrous setup in it because it hasn't been tuned for nitrous. If you're going to go that route, you need to make sure you have all the components designed to work with that system. It isn't as simple as just bolting on a nitrous kit and calling it good. You can't do that when you have this many sensors related to how this engine runs. This engine, I would never recommend running a nitrous setup on it unless you strip 90% of this stuff off, put basic sensor components on it, and run an aftermarket computer. Because the aftermarket computer is going to allow you to customize where you want all your parameters set. And it can actually allow you to help you be able to tune your injectors that you need that is designed for the nitrous and the extra fuel system that's going to get sprayed in, whether it be right behind the throttle body or whether it be that you tapped into the intake manifold and installed those new injectors. APM said racing with hydrogen power engines would be awesome. I'm sure someone does it out there. Yeah, you'll see some hydrogen setups out there. Some people will run them in drag applications. You don't see them so much in road courses, but you definitely see them, you know, in drag strips, stuff like that. You'll see somebody that gets carried away and runs a setup like that. Yeah, it's even ethanol. People will started switching over to ethanol because ethanol does burn hotter, which means you're going to get a more complete burn and get a little bit more horsepower out of it. The bad thing is ethanol also burns really fast, meaning that you use more ethanol. All right, guys. Let's go ahead and cover this right now, the fuels. All right, I didn't want to get this far into the weeds on it, but we're here. So when you're dealing with ethanol fuels, everyone says that ethanol fuels are so great. They're not. They're not that great. The reason why ethanol is even used is because it's something we can make here locally in the United States, meaning we don't have to import it in. Also, we don't have to pay huge refinery costs because the refineries are built on a much more simpler process than what they are for the oil side of things, meaning that there isn't as much of an initial cost setup. There's also less EPA regulations. That's getting much farther into the weeds, into the government side of things. I don't like doing that because that tends to cause my channel to have a whole bunch of weird stuff going on. I'd rather not deal with that. But that being said, ethanol fuel burns faster because it requires more fuel to get the same burn as gasoline. That's the little industry secret that they don't want to tell you, because if everyone knew that, they would stop buying ethanol altogether. The other bad thing about ethanol is ethanol usually contains a little bit of water in it, meaning that water can rust out lines, fuel lines, and can rust out injectors, meaning that it can cause injector failure issues. A lot of newer engines that are ethanol rated to run both are set up to only really run ethanol, and then they're just kind of left floating on the gasoline side. And they're not as efficient on gasoline. They're also not as efficient on ethanol because of the nature of ethanol. This is the truth of the ethanol fuels. Not a fan of them, never have been. If you're ever going to store a car, don't store it with ethanol fuel in the fuel tank. You'll rust out your fuel tank and that fuel will go bad. You need to run non-oxygenated, higher octane fuel like 91 or above. What that does is that stuff lasts for a year. You don't need to worry about the fuel going bad by the time you get back to the vehicle. Now, if you're going to let it sit for longer than a year, probably should drain all the fuel, clean everything out, and put some kind of lubricant inside of the injectors so that they don't rust. That is the proper way to long-term storage a vehicle if you're not going to drive it for a couple of years. I hope that was good information, guys. Make sure you guys hit that like button. Really, we've only got 2 likes. We got 8 of you guys in here. We're really trying to grow the channel. If we want to reach a bigger audience, we need those likes. It burns clear. Yeah, that's the only other thing, is that ethanol fuels do burn cleaner. The only issue that I see with that, though, is we're chasing EPA stuff when we could be getting much better fuel mileage and using less fuel. So that's the alternative. But yeah, ethanol, for me, guys, ethanol is a non-starter issue. I'm not on a track enough to run ethanol and gain the advantage of running an alcohol setup. Also, if I'm going to run alcohol, I'm going to run racing alcohol. I'm not going to run the E85 stuff that we can get on the street. It just doesn't pay. And when it comes down to it, if you're building a machine for that purpose, then it's custom built for that. But again, some of these components would be the same on an ethanol setup. Some of them might change slightly. Some would require more inputs here based on the ethanol. The computer may have to rely on more information from the map sensor and the MAF sensor and your cam solenoids. So it might require an extra sensor wire to the computer to understand what is exactly going on in this setup. So guys, give me likes in the chat if this is all making sense. If not, give me 2 and tell me why. If it's not making sense, give me a 2 and tell me why so that I can help you guys kind of understand this system. Fires are more dangerous. Yeah, ethanol fires, alcohol fires are way more dangerous. That's why for race applications, they're perfect, but for what we're doing here, not so much. All right, guys, there's 6 of you in here. Give me a 1 if this makes sense. Give me a 2 if it doesn't, and tell me why. We've gone into a lot of this here. APM gave a 1. Awesome. All right, you guys all agreeing with him? You guys understand this and you guys are ready to move on, or is there something you guys want me to break down? I'll give you guys just a little bit here more, and then I'm going to go ahead and erase this, and we're going to get into our next part of this topic. I want you guys to have a good understanding of what's here already before I erase this board, because this has to be in your mind when we start talking about how to diagnose this system, how we're going to go from this code to figure out the exact part that's broke. All right, I'm not seeing any more in the chat, so I'm going to assume that you guys understand. There was nobody that put 2, so we will go ahead and erase, and we will set up for the next section. All right, so we're going to erase this. I'm going to leave that code up, though, and I'm going to leave the computer up, because we're going to be relying on that computer setup here for a little bit yet. I'm also going to leave the throttle pedal up here in the corner, because I'm going to explain that throttle pedal in a little bit. Okay, so here we go. I'm going to draw the major sensors. So we're going to have our MAF sensor. We're going to have our map sensor. And we're going to have our throttle body. That has our throttle position sensor, so throttle body. That has our throttle position sensor located in it. Okay. Again, I'm going to do the divide here so you guys understand that there's a motor in here. There's an electrical motor that runs this blade, and then you have the E components in here, the electrical components. Okay. So here is our basics of this system. All right, so APM says zoom in. Sorry about the noise. How is that APM? Let me know. Camera focus is off. Okay. All right. So now that we got, guys, there's 12 of you in here. Thank you for tuning in on this Saturday. Make sure you guys hit that like button and the subscribe button. It really does help. It helps us to build the channel and helps us bring more content like this. Better now. Okay, good. All right. Thank you, APM. So here's what we got. So how are we diagnosing this code that comes up? Again, when you guys saw the drawing and we had everything here, our map sensor was located on our intake manifold. The code that came up was for this. So this is where our code was. code was saying there was something wrong right there. What we could do is chase this. The problem is if you've put a new sensor in and you're having issues with idle, then this wasn't your problem. This wasn't bad. What it was doing was giving your computer the information. Again, I'm using purple for information. It was giving information to the computer that something was wrong inside of your intake, meaning that you were either too high on pressure, too low on pressure, meaning you might have had a bad seal around your throttle body. You might have had a bad seal at the map sensor. But this code tells you where to start looking. Your quick way, again, like we said, if you don't have a scan tool that can see this measurement right here, if your scan tool only gives you a code, then you have to chase what is related to that code. If the sensor is not that expensive, you can replace the sensor and then see how the system reacts. If it doesn't react well, there might be a relearn procedure with certain map sensors, and throttle position sensors. We will go over that in just a bit, the relearn process. But this needs to know that it's getting the right reading, meaning that if this is the right reading from here, let's say it's sending the fault code to the computer is throwing the code to your OBD-II port because this is actually reading properly. It's reading a high or a low reading, meaning that air is either getting in or out of the system when it shouldn't be. Then what you're going to do is, once you've replaced this and it doesn't work, you're going to put the old one back in. The reason you go back to default and why you never throw away old sensors until everything is running right is because you need to verify that this was the problem. When you can't see this measurement to know if this is working right, or test your map sensor with a really powerful OBD-II scan tool, then what you need to do is to be able to go back to default and chase down what could be causing the problem of this code. And what could be causing the problem of that code is right here in your throttle position sensor. If you don't have a leak at your intake, if you don't have a leak on your throttle body, then the only thing that's going to throw a weird code, if this seal is in good shape, is your throttle position sensor. The reason that this will throw that code is because it's throwing it off at the map sensor. So your map sensor is the one that's actually off because your throttle position isn't reading right. It's trying to read at a higher level than what it's supposed to. All right, guys, give me ones if that makes sense. Give me twos if it doesn't, and tell me why you're having troubles understanding or what doesn't make sense to you. So one if that understands, two if it doesn't, and tell me why. Oscar, shot a one. Awesome. Nice to have you in here today, Oscar. All right, so if we don't get too many more people chiming in with on the ones and twos, then we're going to break off into how we figure this out. Okay, all right, guys, make sure you guys hit that like button, hit the subscribe button. It really does help build the channel. We're really trying to do some good stuff. I'm trying to bring you guys merch, so just know that we've got this in the process. We're working on it, but we got to get there. We got to get our subscribers up. We got to get our views and our likes up. So now that we've determined that this sensor is good and that it's giving a proper reading to the computer, but it's throwing this code, now we need to look at why it's throwing that code and exactly what the details of that code is. Well, When you look up that code, it is the code actually is related to high reading. Okay, so this is reading high. Well, why would it be reading high? We didn't change our fuel. We didn't change our air because we didn't do anything different with our intake. But why would this be reading high? Well, if we're not changing fuel, let's say we're not throwing an alternative fuel in this. We're running stock pump gas, and we have been. So it can't be fuel related. Our next point is the point to the big one that does most of the controls on your vehicle. So, you guys are seeing what I'm boxing here. This has the most control, the most amount of wires going to it to control everything related with the car. It takes all the information from the computer into this to make it run right. What it's also doing is giving information back to the computer for the injectors. If that is not reading right, what it can be related to is an air or a throttle position sensor not reading properly, causing our high reading. Give me ones if that makes sense to you guys. I just broke down what that code means and why we chase it the way we do. Still here, I was running the vacuum, couldn't hear. Yeah, I can understand how that goes. I did hear most of it. Hopefully everyone is having a great day. Please hit that like and subscribe button. Yeah, guys, make sure you guys are hitting the like and subscribe. It really does help build the channel we're trying to build this year. I'm working very closely trying to build up my wrench squad and my mod squad. You guys are awesome. The more people that I can get into my mod squad, the better we're going to be able to do stuff in the future. I've got some big things coming up, guys. I'm going to show you guys the project car that we're working on here once we get done with this. I really did need you guys to kind of understand what the problem was with this code before I got too far into the weeds on this repair. I really wanted you guys to have a good understanding of this entire electrical system. If you guys want to work on your own cars, you guys need to understand these components. You need to understand your throttle pedal, what it does. You need to understand your throttle body, what it does. You need to understand this MAP sensor, this MAF sensor. And you need to understand the main function of that computer and what it is designed to do. If you don't understand how these are all tied together, then when you put this sensor in and it doesn't run right, you're going to get frustrated because this was the code that came up. This is what should have been wrong. That's not how the automotive industry works. That's not how the computer works. And this is the biggest thing I needed to teach you guys today is the computer takes all the information from all its surrounding sensors, then sends information back out to the sensors needed for the response. So this will not have purple wires. This will not have a sensor. This only feeds information one way. So this only feeds information to computer. This only feeds information to computer. This will feed information to the computer, but this also receives information from the computer. So you'll have a two-way signal. And the easiest way I could do this without you guys getting confused is to go this way. So, information from computer, boom. Information to computer, boom, like that. So this is how the system works. This is ran on a loop system, meaning that this will give information and receive information from the computer. The computer is the main control here on this one. Also, when you're talking about those solenoids that were those cam solenoids, those give information to the computer as well. So these give information to the computer. These don't actually receive any information. And what they're giving you is the information of camshaft position, location, things like that. Once you've verified that these are in good shape, you don't worry about those. Usually if those go bad, you get an idle position code. So if you get that idle position, most people, this is another one that people get wrong. So like this one can give you a false reading because this is actually reading right, but it's caused by that. You can get a faulty this, and you think it's up here because the idle is controlled off of the camshaft. So those camshaft solenoids are what does a lot of the idle control. Meaning if you get idle that sticks or hangs high or doesn't settle down like it's supposed to, and you start getting that idle code, you look towards those solenoids first, then go to your throttle position. Throttle position in that scenario is last. In this one, once you verify that this is good, then your problem's here. All right, is that making sense for everybody? One, if it does, two, if it doesn't, and tell me why. APM dropped to 1. I'll give you guys just a little bit here before I erase it, and then we're gonna Oscar 1. Awesome. Okay, so what we're gonna do is we're gonna move forward here. I want to talk about the two different throttle bodies. I'm gonna leave the computer up for just a bit because I'm gonna use the computer later on when we talk about throttle lag on GMs. But we've already talked about how the P0106 code is, how to chase after it. The reason that you'll use sensors, like new sensors, to diagnose problems when you get these weird codes like this that doesn't seem to fix the problem is because using a cheap sensor to diagnose the system, if you don't have a scan tool, is a lot more affordable. You don't just run out and buy that throttle body. That doesn't make any sense. Going out and just chasing components that are really expensive, we have a term for them. They call them part flinging monkeys, meaning they just huck parts at it until they finally get it right. We're not hucking parts at it. We're figuring out which parts are working properly. Then through reasoning, we're going, why are we getting that code that we had into the entire system if that sensor is reading right? What is our next logical step? And it always points back to that throttle body because of how much is going on inside that throttle body. So let's talk about the two different throttle bodies. So we'll have throttle body A, throttle body B. So I'm going to say A and B. Okay? Throttle body A, throttle body B. One throttle body has a big black box on the side of it with a connector. Sometimes it could have two connectors. Sometimes it'll have a big long connector. Either way, it has the box with the connector. The other one has an articulated arm that comes off and through. On that articulated arm, there's a pulley. On that pulley, there is a cable attached that goes up to your throttle body. This is old school. This is racing now. Most people will use this when they want a direct link to their throttle pedal. This is what system we used to have up until about 15 years ago. 15 years ago, everything switched and went to this system. So 15 years ago, it went to this system here. And what this does is it sends a signal from the pedal for how hard you press to the computer. The computer diagnoses that signal, corrects the air-fuel ratio, to remain at 14.7. Stoichiometric. We talked about that a little bit earlier. So it will adjust based on what you're telling it to do to maintain the stoichiometric based on the amount of air that's coming in off of the mass airflow sensor. So as that air comes in, that's going to then adjust the air and the fuel to make sure that you remain at that stoichiometric. This is where a lot of the problems happen now. You can have computer problems, don't get me wrong, don't get it twisted. Computers can go bad. You can have bad faults in a computer that causes a lot more problems. That doesn't mean that your computer should ever be taken out of the equation when you're dealing with issues. But when you're dealing with a single fault engine code and you verify that the sensor that you've replaced associated with that code is working properly, you have to look at what that sensor does, what it is its purpose. On a mass airflow sensor, if it was to throw a code of a mass airflow, oftentimes the heating element inside of these go out. Also the temperature can go bad in it. These things adjust based on air temperature. So air temp makes a big difference on this sensor. That temperature, along with the volume of air, is sent to the computer. This is how they calculate how much fuel to give it, based on how much air is going in and the air temp. Those two readings are what make up your air-fuel ratio. So the manifold pressure code that we had before, that was tied to a bad throttle position sensor. And I'll show you how we diagnose that here in just a bit. But I want you guys to understand the two different settings we have here. The two different setups. One is old school, one is new. People love to do that with stuff. Horrible. We call them parts chasers, LOL. Yeah, APM brought up a good point. So guys, anytime we're just throwing parts at a problem to try to solve it without doing any kind of diagnostic processes here, this is where we run into problems. This is why projects get snowballed and why it costs so much. This is why you guys pay mechanics. Guys, seriously, give me some likes here because I'm bringing you guys straight up fire content of how to diagnose your car and really how this system plays together. You guys will be able to play this video back at any time and understand the complete system that's associated with your fuel ratio. You guys will be able to look at the problems and see the codes that are coming up. And if you guys got that code in your computer, this P0106 or this P0107 or P0108, if you get those codes, I have literally explained everything right now on what you guys need to do to be able to fix those codes. This is how you would go about it. You're going to chase the map sensor first, because if this code comes up, this one is the map sensor code. You're going to chase this one first and make sure this isn't good. Remember, if the part is only 75 bucks or less, put a new one in it to verify. If you're still having idle issues, you're going to put the old sensor back in, and then your point that you're going to look at is right there on your throttle body. It's actually going to be here in the drawing we did so far. Everything today, I've done comp is down here. So this is where your information center is on your throttle body. This is where all the information either comes in or goes out based on what's going on with the engine. All right, ones, if you guys understand the two systems, old school versus new. B is the old school, guys. It's just a straight up cable attached to the throttle. There is no wires, there is no connection. The computer, on a system like this, if it is fuel injected, what it's going to have is a separate throttle position sensor that's not located built into the throttle body. It's going to have a throttle position sensor located usually on the other side of the linkage or within the throttle body. And what it's measuring is how much that blade is turning. Then that information is getting sent to a computer. Oh, that's the wrong color. Trying to keep these colors straight so you guys understand as we go today. This will send information to a computer. It will not receive information on the old school. It only sends that information to the computer. The computer then uses a airflow sensor to sense the temperature and the amount of air coming in to adjust the fuel and either send more fuel from the injectors, or if it's a system that's even more rudimentary, it will adjust the timing. All right, guys, give me a 1 if that makes sense to you. I have to hit the road to go to the shop for the welder. I'll try to chime in when I can. Thank you, APM. Yeah, please keep checking back, APM. Guys, if there's any more of my wrench squad in here, make sure you guys are chatting in. APM, hopefully we can hear from you later yet today. It's always good to have my wrench squad in here. You guys are awesome. I really do appreciate having you guys here every week. All right, so I'm not seeing anything else. Let's go ahead and move forward here. So this is our setup. Now we're going to get into the throttle leg on the GMs and even on some of the newer stuff nowadays. And this is going to come back up. The reason I'm doing the explanation video, guys, for you today is because we are going to chase a way to solve our throttle leg. But I need you guys to understand what causes that throttle leg in the first place. So I'm going to move the throttle pedal down so we can see it a little bit better. So we got throttle pedal. So there's our throttle pedal. There's usually a connector on it with a box. So spot where wires would get plugged in. There's our throttle pedal. Next, we're going to have our throttle blade or throttle body. And because we are dealing with an electronic one, I'm going to draw it as an electronic throttle body. So that way you guys aren't getting confused. Okay. Okay, so now we got our throttle body. Okay, so when we're dealing with drive-by-wire systems, guys, this is why it's so important. Bad Wrench Squad 100%. Heck yeah, man. Heck yeah. I will keep the live going, but I will be behind the wheel for about 15. Cool. Yeah, thank you for keeping the stream going and bringing more people in. Guys, the more we engage with this content, the more likes and the subscribes we get, the more we can grow this channel. I'd really like to do some different things for you guys this year. One of those being, I'd like to bring you guys some merch, okay? So we are working on this for the future, but we got to get our subscriber count up and our engagement up. We need to make sure that we can reach a bigger audience so that we can actually sell the merch that we're going to try to put out there, hopefully within the next month or two. Kind of depends on how things go with the channel in each video. So the more engagement we get, the more you guys interact with the content, the better it gets. So we're working on that. My wrench squad is awesome. You guys are awesome. Love having you guys here every week. All right, so let's dive into this. This is a drive-by-wire system. And drive-by-wire can be extremely frustrating. What will happen is this will send a signal down to here and go into your computer. Your computer will also send a signal down to your throttle body. Okay? This isn't the complete picture. And this is where people go wrong, because they automatically assume that whatever happens here is going to happen here, and it's going to happen here. That isn't the case. In GM, shame on GM, they have chosen not to update their throttle position systems for the last 15 years. This problem lies in every vehicle built since 2010. They have not adjusted their programming to be able to do anything different. Let's talk about the stepper motors that everyone hates. So everyone assumes because there's a motor in here that runs that blade, that that's the stepper motor. You'd be wrong. This is not your stepper motor. Your stepper motor programming is up here in the computer. When you go to give this gas, let's say you accelerate hard, what's going to happen is this tells the throttle position to tell the motor to open in stages. It doesn't mean that that only works in stages. That ain't what that's saying. What's happening is the computer is slowly sending voltage to the throttle position to tell the motor to slowly open, meaning that it doesn't just snap open and respond directly to your foot feet. This is the problem with GM, guys. This is where we run into so many different problems on the throttle position side, because we run into too many problems where that system is now almost outdated for what we're trying to do with it. It doesn't make a lot of sense because it's not actually giving proper feedback based on what we're doing with the gas pedal. And that has been the problem from the beginning. Meaning this problem has been there for the longest time. And they haven't bothered to fix it because they don't have enough complaints from owners and customers to say this horrible system sucks. Replace it. Figure out something else. We hate that when we press the pedal, it doesn't respond to our throttle body. They're not fixing it because we're not bringing it to their attention. What they do on the high performance setting, guys, they're doing on the high performance setting, so let's say you have something like a Corvette, Camaro, something of high performance, okay? You have this system here, which is our old system that we just talked about. Okay, you have that. But now on the high performance settings, the ones that are built for performance and speed, you have another one here, right there. This doesn't exist in their base models. This also doesn't exist in anything that isn't considered their performance line, such as their Corvettes, Camaros, or their high-end pickups. Some of your high countries may have it or may not have it, depends on the throttle body. And if that throttle body correlates to an old part number related to either a 4. That's the only way you get that secondary line there. And what that does is that instantly removes all throttle leg. It instantly takes care of it. It eliminates all throttle leg instantly because you're going directly from the pedal to the throttle body. But that doesn't exist in most of the models that they make. Most of them are the other system that does not have this wire. And if it doesn't have that wire, what happens is then you feel the stepper motor, or stepper motors is what they like to call them. Basically what happens is it just sends a slower signal to your throttle position that then tells the motor to do something different. So how we can alleviate this problem is we can either tune the computer to stop doing what it's doing, which is very difficult, and on newer computers, I'm gonna make sure I get the year right. (2015) was a pivotal year for automotive industry, especially on the GM side of things. What happened was they locked the computers, meaning we could no longer tune them. We could no longer go in and change parameters. We could no longer go in and adjust anything. The computer was the computer was the computer. And unless you had the special code directly from GM, you could not do anything with this system. So their stepper motor problem that came from their computer programming was now permanently hardwired into the computer, and we can't change it. Give me ones if that makes sense to you guys. Give me twos if it doesn't, and tell me why. All right, we got a 1 from APM. Come on, guys, smash that like button, hit that subscribe button. We do this every Saturday at 1 p.m. I am sharing with you guys my knowledge on automotive, and I've been doing this for 30 years, guys. Mike Gordon, good to have you in here. He also pressed a 1. Awesome. Like I told you guys, the only reason I don't have a dyno in here is I don't have the room for it. It's not that I don't know how to tune. And if you guys want, tell you what, how about this? Everyone in here. If you guys want me to give you another story about stuff I did that resulted in dyno stuff, give me a 4. Put a 4 down in the chat right now if you guys want me to share another story of a dyno experience that I got. While I'm waiting for that, we're going to go ahead and move on. How do we fix this problem? If we can't tune it, because most cars now are going to fall underneath this. This is a 10-year-old car, guys. 10-year-old car, computer's locked. We can't do anything with it now. How do we fix this? How do we fix the communication problem between here and here with these stepper motor programs that they put into the computers? Oh, Mike and APM with a 4. You guys want to hear another dyno story? Awesome. Okay. Unlocking isn't cheap either. Yeah, unlocking isn't cheap. And actually, after it's going to be this one or this one. After one of those 2 years, you can't even unlock it. You are not able to unlock. The lock is permanent in the computer and you cannot adjust it or change it. The dealers can't even go in and unlock it. That's the problem with the GM side of things right now. Why GM is about to actually wind up getting just absolutely decimated in the performance industry. It's because they've locked their system so much that nobody can actually do anything with them. Yep, HP Tuners has already said that they can't. And why is it? Because after that 2015, they couldn't get by the codes that the manufacturers put in. They're locked at the manufacturer, not the dealer. Dealer has no say in it. The dealer has been taken completely out of the system of being able to get rid of this problem. This problem has caused me more frustration and more problems and more pain on the dyno side of things than anything else. It's absolutely frustrated me how this all came about. I know I saw a little dip in the viewers when I started spewing right there, but I'm trying to get it through to you guys that this is the major problem. And this isn't only in GM, guys. This happens in Ford. This happens in Dodge. This happens in all of the modern gas engines because they think they can save fuel by doing this stepper motor program. And I'm gonna write program up here. I don't want you guys to get confused. So it's a program. That program is in this computer. The computer sends the information to the throttle position that then controls the motor. The motor would snap that blade open so fast, faster than your foot ever could. There's a product we can buy to fix that. There's actually a couple of different products we can buy to fix that. One of them I don't recommend, and I was thinking about it a while ago, and I never went to buying that product because I knew that it was going to cause problems. Because we've had some recent YouTubers, I would say in the last probably year or 2 years, have massive problems with this company. I'm going to go ahead and write them on the board. I don't want to say their name because I don't want to cause any other issues. Okay, you guys can read that. That's the one I don't recommend. The reason why is their programming actually does damage to the motor. Well, I should say it does damage to the pedal, the computer, and the stepper motor, or the motor, not the stepper motor. The stepper motor is a program in here. But it does damage to this motor, does damage to the pedal, and can potentially damage the computer. This is why I haven't gone with too many. I have 2 videos, dogging Snap-on, kinda waiting for the letter someday. Yep. Yeah, so anyone who buys something from like Snap-on Tools that says that they can program your vehicle, it's BS. They can't. What does this product, that I don't want to say their name, what do they do? When you plug this in, what does it do? I'm going to draw this out over here. Okay. There's that lovely system that you get. It comes off in 2 different connectors. Let me draw that differently so you guys can understand. Okay. Comes off here, comes off here. Connector there, connector there. Okay. So you have a connector here on this one. Okay. You're removing this connector off of here and plugging it into here. And then you're plugging this connector into there. Every throttle response system operates just like this. There is one product I'm looking at right now that's called Roar Pedal. I am considering getting their product and testing it on Malibu steel. This system would basically do the same thing that this one's doing, Again, I'm going to erase them now. I've left them up there long enough. This is the one I'm looking at. I'm dropping you guys some sauce here. Don't be going and buying this product and spoiling my videos later. Don't be dropping stuff in my chat saying how much you guys love that product. But what this does, APM said BMW had the technology in the 2000s. Only reason I say potentially is because I have seen a few old ladies send it. Yeah. Yeah, there is a lot more out there that have done systems like this for, long before it became popular here in the US. Europe is usually ahead of the trends, especially like anything German engineered or like BMW, anything like that. They're ahead of the curve. So we're going to see this happen across the board in so many different industries that we're not late to the game, but we're not early to it either. So what this does is takes the signal that your throttle is putting out and then actually amplifies it to the computer. So the one, when we did our connection here, what it's doing is it was sending the signal to the computer. Now that signal is going here instead and then going here. So now the signal is going from here into the box. It's getting redistributed and amplified based on the program settings that are in here and then sent to the computer. What that does is it eliminates the stepper motors. It eliminates that stepper motor program and allows a direct link to the system. And what it feels like happens after you've installed that is it feels like this. That's what it feels like. This is the only recourse that we have in the system right now, guys. This is the only way that we can fight against this issue, is we have to install these secondary items. The only problem is some of these secondary items do damage to our main components. And we have to be careful which ones we buy and put in this system because we don't want to damage. If we damage this, that's a bad day. It gets real expensive real fast, real costly. And if you don't have a good enough computer to be able to reflash one, now you're back at the dealer. And it's all because you put one of these in here. That's why I won't use that other brand that I wrote down. I don't use it because I already know what's going to happen. I've seen enough videos on it, and I've seen enough people get frustrated at the fact that they had no way to get recourse back after what happened. Give me ones if that makes sense to you. Twos if it doesn't, and tell me why. APM with the big one. So this is how that system works. This is how all the commands are being sent. There is information being sent to and from the throttle body. There's information being sent to and from the computer. Jerry with too much junk now these days. Yeah, that's the problem. That's the problem, is this became an overcomplicated pile of crap. And we're forced to deal with it because of the locked computers. Because all the computers became locked in 2015 to 2017, we're stuck dealing with this. Half the time when you hit the throttle and it lags, you don't even have anything wrong with it. It's just how it was programmed. And you can't change the programming now because this is a 10 to 12-year-old car. Or 8 to 10-year-old car. So depending on what you got, that could be, could be one of those things that you're now going to have to live with. And I had one of these trucks I bought brand new. Had one of those brand new Trail Boss. I'll tell you the guys this, and then I'll get into the dyno story. So, I had a 2016 Chevy Colorado, and it was a Trail Boss. Trail Boss is supposed to be an off-road truck. As soon as you hit the throttle, it would go to the computer. Computer had a lag in it. As soon as it went from the computer down to here, it again had another lag. That's why they call them stepper motors, meaning that there's more than one step to make that motor move. That's in the programming, not in that motor. Because there was so much lag between these two components, it caused this thing to go flat on its face, meaning it had no power. As soon as the power kicked in, it kicked in hard and it kicked in fast, and then all of a sudden fell on its face again. Because the programming wasn't right. Because the programming was offset so bad that it couldn't actually respond to what the throttle pedal was doing. APM, my buddy, 2013 Avalanche, do slow compared, or is slow compared to my 2001 Yukon. I do have a bigger engine, but his is crazy slow. That's some of the reason that it's crazy slow though, because of this system right here. He wants to get this system unlocked. He needs this. He needs to put that component in there because that's the only way he's going to get rid of it, because it's hardwired into the computer. We have to bypass it. We have to bypass that throttle pedal in order to actually make the computer do what we want it to do. Off-road for GM is dirt for the new vehicles. Yeah, basically, yeah, I took it to the dealer. I raised a stink shit fit about it. And I told him, you guys are buying this truck back. I'm not going to keep it. Can you bypass a stepper altogether? No. Just as we're saying here, the reason we can't bypass these stepper motor, which is a program, it's not the actual motor. We can't bypass it because in 2015 to 2017, the computers were permanently locked from the manufacturer. This was done to keep people from tuning their cars. This all came about because of the administration that was in charge at the time, made it a rule that all computers had to be locked so people couldn't modify or tune their cars. This is all because of and if I misspell them, I don't really give a crap. But it's all because of them. They're the ones who pushed it. They pushed it at the state level to where it got to a point that it went into the federal. And the minute that it went into the federal, it just got carried away from there. After we were talking or taking off, I said it had I said, is that floor? And he goes, no, wait. Yes, I am. I was thinking it was 30 mile per hour after 7 or 8 seconds. Yeah, his problem is right in here. This is his problem. And newer vehicles are 10 times worse. That's what it is. California was the one who started pushing this shit. They're the ones who started pushing the problems. That's why we're stuck dealing with this garbage now. And why on all the older vehicles, after 10 years, stuff that's older than 10 years, we can still do a little bit too. But as soon as we hit these dates, we hit a wall. And that wall is a locked computer that we can't adjust, we can't tune. And it's whatever the manufacturer decided to tune it. And we can tell you right now that half of their tuning programs are all messed up. They're either old or outdated, or they don't work properly. That's all because of their bad designs. All right, guys, give me a 1 if that makes sense, 2 if it doesn't, and tell me why. And then I'm going to get into another dyno story for you guys. Make sure you guys hit that like button, hit the subscribe button, ring that notification bell. We do this every Saturday at 1 p.m. Central, guys. New topic every week. Some people get upset that a lot of the older vehicles blow most of the newer ones away. That's because the older technology isn't slowed down by bad programming. That's the problem. And I can tell you right now, the top 25 programmers in the US right now could fix this problem in less than 1 hour. But they can't because the computers are locked. Yep, APM, you're right. Get the big screens to distract you from the uncomfortable seats. Yep, that's what it is. We have given up technology for performance. That's why all of this crap has to happen. That's why we have to put products in to bypass what this does and the information that this gives this. We have to put secondary products in to fix performance stuff because they won't fix it. That's exactly what this is. Jerry with a 1. Awesome, awesome, awesome. 1 if this makes sense, guys. 2 if it doesn't, and then specify why it doesn't make sense. I don't like to move on unless I know you guys understand, because it does all tie together. And the more we understand that, the more we can fix the problems. APM 1, awesome, awesome. So yeah, the more we understand how this system works, the more we can understand what we need to do to fix that problem. And when we start looking at this as a broader picture, not just a throttle body issue, not just a computer issue, and not just a pedal issue, we can start seeing how we can fix this even with a locked computer. And that's what this product does. Again, there's another product out there. I had them on the board earlier. I don't want to write them back up there again, because there has been a bunch of stuff that's happened with that company, and there is a potential lawsuit for them damaging throttle pedals, motors on throttle bodies, and computers. There has been several big-time YouTubers that have used that company's product that I don't want to say. It's not written up there, but I don't want to say them. And they put out lawsuits against the company because of how much it's damaged their vehicles. Jerry, so you're better off with older car or truck. Yes, Jerry. Here's what it is. When this gets locked, you can't do anything. All you can do is replace whatever the computer tells you is wrong with the car. You can't adjust anything in here. Nothing can be adjusted here after this point because it's locked, meaning that the stepper motor program that's in that computer that slowly tells the throttle position to move the motor. Again, your stepper program is from here and here. telling your motor to slowly open the throttle blade on a stepped setting. You can bypass that with that product, but you have to plug it in line and then set it all up. And what it does is it takes the connection from here into this box, it amplifies it and corrects the signal in here, sending it to the computer, which gives it a different signal so that it eliminates that programming. That's what it does. And for the longest time, we had, Banks had one out there too. I think theirs was pedal power. Theirs was more for the truck side. So if you guys are dealing with the trucks, Banks is a good company. They've done a lot of research in their stuff. They know exactly what it is. And they fixed the problem from that other company. They fixed the problem from these guys. They fixed the problem from them. Because what they noticed was this company amped the signal here. And when they amped the signal, it wound up fuzzy and unclear. And because it wasn't getting a clear signal, what it did was it sent a lot of fuzzy signal to the computer, which caused the computer to eventually short out. And also what happened was when this was getting a fuzzy signal, it sent it right back down here and caused damage down there. Guys, this is stuff that tuners know. Tuners know this stuff, not the average person. Because the average person doesn't take the time to look into why this system is working the way it is and where the faults are. Tuners do, because tuners have to deal with this all the time, especially when they're dealing with something like a Camaro, a Corvette, a Mustang. They have to correct the problem that these manufacturers put in through their stepper motor programming. APM, Banks is awesome. Yes, they are. Absolutely. If you break one of their transmission pan things or rear diffs, they send you a new one free. Yep, they do. They have a breakaway transmission pan cooler scoop. Yeah, they've got, Banks is top notch. Banks is a good company. I trust Banks. I do. But for a lot of the stuff I got, Banks isn't going to be able to help me that much. Need a great hacker, computer hacker. Here's the sad thing. This happened at this point. People are still trying to get codes done, crack those. They're still working on it 10 years later. The manufacturers have kept that so tight-lipped that even a good hacker can't get past it. They've tried. What happens is they wind up buying all the components. All right, I'm going to spill some sauce. Guys, hit that like button right now. I'm about to tell you guys how you get unlocked computers. Hit that like. I need 6 likes. Hit that like button. I'm about to tell you guys how they get unlocked computers. All right. Signal was a little weak there with the wind. Give me 5 likes, guys. Give me one more like. Come on. One more. The encryption is ridiculous. Absolutely it is. And they know it is. APM, they can't backdoor these because they've only allowed certain people access to the codes. And those people are forced to sign a non-disclosure. All right, we got the 5 likes that I was after. Okay, guys, how do they get unlocked computers? They buy all the components separately, and they don't put a program in it. Now it's an unlocked computer because they bought all the components without a programming in it. Now you have an unlocked computer. That's how they're doing it. Yeah. I'm just kidding. Yeah, no, the reason that you can't get GM to give these up is because they keep very tight-lipped, and all the manufacturers have had to because of that bill that was passed. Think about it, guys. Who was president at the time that happened? Think long and hard about it. Who was president at the time that happened? Damn EPA. Yep, that's one of them. But there was someone else who pushed it that was much higher than the EPA. He just used the EPA to do it. He's also the same one who gave us the cash for clunkers bullshit. Another thing later on I might do a whiteboard on for you guys on that cash for clunkers crap. He was responsible for that. APM got it. You guys can check the chat for his name. That's right. He was the one responsible for this shit. He's the one who caused this to get locked so that we can't have anybody tuning cars. We don't get to have performance. We don't get to take a stock street car and turn it into something fun. He took that away. That's what happens when we let politicians run their mouth in the automotive industry. That's what happens when we let them run free and wild. The only way you're going to be able to beat that is you need to find ways around it, and sometimes they make it to where you can't. APM, cash for clunkers was a disaster in reality. Yep, absolutely was. Give me some thumbs up down below if you guys want me to do a video on cash for clunkers crap. If you want me to break down exactly how that happened and what the purpose of that was. I want to see some thumbs up down there if you guys want cash for clunkers scam. And that's exactly what it was. It was a scam. APM with the big thumbs up. Awesome. Let's get a few more people to throw some thumbs up for if you guys want me to make a video on cash for clunkers. Jerry, looks like I'm staying with my 2011 5.3. The only thing with your 2011 5.3 is make sure you get that variable valve timing turned off so it doesn't destroy lifters. That's the only other problem. Variable valve timing went in. VVT started in 07. Started mid-07. So anybody with a vehicle after mid-07, you have potential lifter failure issues. Usually starts happening around this mileage range. Starts happening right around then. And the reason that happens, I know, done had to. Yeah, it happens right around that mileage because that VVT system is a poor design. That poor design, coupled with this poor design, has made GM a vehicle brand that most people do not want. And when it comes down to it, anytime that they have a V8 VVT, because it's shutting down cylinders, it does way too much damage. Meaning that when the lifter fails, if you don't catch it right away, it takes out the engine. Jerry, delete it all. Absolutely. NFS Carbon 2. Mitsubishi Evo 8. Minvec 1000 horsepower street setup with concrete. If you've got that kind of setup, man, you've got one hell of a car. I can tell you right now, the Evos are no joke. I had a friend of mine who had one of the all-wheel drive Evos, and that car was, I don't want to call it scary because there's only been a few cars that have ever scared me. but it was one of those cars where I definitely took notice, and it was not hopped up at all. The car was pushing almost 400 horsepower, and it was insane. So yeah, NFS Carbon 2, if that's your car, you got a nice setup there, man. That's no joke. But yeah, this is the problem that we now face. And it all happened during this time frame under a president who didn't give a crap about automotive. In fact, he didn't care about it so much that I'm not going to spill the secret yet, but I'll let you guys know that the cash for clunkers thing had a much more deeper, sinister meaning to it. But that will be a video for a different time. So, now that we've covered this and we've covered what we can do to fix our stepper motor program, next we can talk about other diagnosis and other ways that we can diagnose other problems. So, what do we got here? Thanks. Yeah, dude, that's a serious car, man. That's no joke. Go ahead and drop down below. What mods did you do to get to that power level? Because you had to have done some stuff to it. Stock, those Evos are only usually pushing roughly, I want to say between that 350 to 400 horse. So you must have done some stuff with it. Can drive that through a ditch full of snow. Yeah, the design of the Evo 8 really matches the sound it makes when you wake up, the power it can make. Yeah, let's drop it down there. What did you do to get that power out of it? If you don't mind spilling some of your secrets on that. Because 1,000 horsepower is stout. That is to be respected, no matter what the brand is, guys. Plain and simple. We don't knock people over here for having horsepower and different brand stuff. We don't. Seriously. When you got a setup like that, what did you do to get there? Because that's a serious machine. We don't knock people for having different brands. When you got that kind of power, you deserve to be respected over here. So that was a good setup. Also, guys, what other things are we starting to see with codes that you guys might think are problematic? Let's drop those in the chat down below. I'm going to read the chat here while you guys are chatting stuff in. What codes are giving you guys troubles that we can look at that might be a potential something else? And what I'm referring to is anything that's related to a sensor issue that would be tied to a computer. But that's not, the problem isn't here. The problem is in a different component. What else do you guys know of that we can look at that would have a similar setup like that? So what kind of power do you think you can get with my 5.3? Okay, so you're talking, let me erase this here for a second, guys. I want to point this out. Okay, so he's saying he has a 2011 5.3. This is probably going to be, it's still going to be, I believe, the first gen. First gen 5.3. Actually, I got to stand corrected on it. That's second gen, because first gen did not have VVT. It's got a second gen VVT. Jay says, APM said 1,000 from a 5.3 is easy. With power adders, yes, it is. Without power adders, you're not going to get there. And again, the reason that you're restricted, computer's what restricts you from getting there without power adders. What is the check engine light goes away, but you don't realize you were still making wear and tear to your engine. APM, 2GT turbos, and the fuel. Yeah, okay. I'm going to get to yours in just a second, Jay. I want to answer this one that just came in before you. What kind of power can you expect from this setup? Let's say on natural pump gas, just natural. Let's go 91 because it's easy to get at any gas station. Here's the numbers that you can expect, and I'll explain how you get there. Okay. The reason it's such a wide range is because it depends on what components you put into it. It really does. If you're just looking for a mild build, you can simply bump the compression and you can pull the lower number without a problem. Most of them are pretty close to this number already. Most of the time, factory 5.3s only came with either 300 or maybe scribbling too much. That was factory numbers. So, simple heads. If you put on a set of Vortec heads or you put on a set of aftermarket aluminum heads, you can bump that power up pretty quick. That's one way to do it. The next way to get that number up is a cam swap with a tune. And you can start getting closer to this mark here. With a cam tune and heads, you can get really close to that number. And you're still running pump gas. Let's say you want to get a little carried away. Let's say you want to push up near this range. Okay, you're going to go that range. You're going to be looking at a wild cam, a tune, probably a complete engine build. You're definitely in that tune, you're going to have to program it for race fuel. You won't be able to run on naturally aspirated or natural pump gas 91. You're going to have to go something stronger than that. So those are what you can expect out of decent street numbers. And let me put it this way. Out of a stock vehicle, that's a stout number right there. That's stout. Our GMC Jimmy, our 01 Jimmy, Crimson Vortec, stock only had this much horsepower right there. That's all that the GMC Jimmy has. Oh, we got a bunch here from Carbon 2. Guys, he listed everything he did to that car. He's got Super 99 turbos in it. Four-cylinder head has been modified. Yep. He's got racing valves in it and springs. I want to put the spec here, but YouTube will not allow me to write it all in one go. Yeah. Yeah, he's got quite a bit into that car to get it near 1,000 horsepower, guys. That's insane. Yeah, that gives you guys an idea what kind of money he pumped into it. So that's what you can expect from yours if you start playing around with it. If you want to get any decent power, you're looking at a complete engine build. Just make sure you figure out exactly the process that you're going to go and what you're going to run. Don't build an engine without knowing where you want to take it. If you're going to build an engine, you need to know if you're going to run, number one, you need to know, are you running power adders? Number two, fuel type. Number 3, budget. Number 4, complications you're going to run into or problems. Those are the top 4 things you worry about when you start building. Number 1, are you going to run power adders? Number 2, the fuel type you're going to run. Number 3, your budget. Does your budget actually match what you want to do? Have a great day. My connection is bad. I'm on low 4G. That sucks, man. Thank you for tuning in, though. We do this every Saturday at 1 p.m., guys. That's when we do this. 5 to 6 would be great for me. Thanks. Yeah, no problem, Jerry. That's what we can do to get you there. If you want me to kind of give you an idea of where to go to get there, you can chat that in, and I can do a quick layout for you, tell you what to look for. Let's go back to Jay's question here, who says he keeps having a check engine light that goes away. But you don't realize you are still making wear and tear to your engine. Yes, there are certain codes, guys. There are certain codes that are default trouble codes that when they come up, it's a shut it down and don't run it. And here's what I would tell you. First thing, oil pressure. Anything that messes with oil pressure. If your oil pressure drops for any reason, you need to shut it down immediately. Stance car build pros and cons. So you want me to break down like the problems with doing stanced cars, whether you're dropping them or raising them? Let me know that in the chat there. So oil pressure, yeah, that's number 1. If you have any oil pressure issues, instantly shut your engine down. Number 2, if you have a misfire. If the engine keeps popping or doesn't want to respond or has a dead spot in it, shut it down. The reason why is what happens is the fuel can build up in the cylinder and cause you to blow a hole in the piston. It can also wash down the rings and put fuel down into the oil. Yeah, problems with stanced cars after this question. Okay, so misfires. You definitely want to make sure that you're not having a misfire in the engine. Anytime you hear a popping or a pinging noise, that's not a good sound. Next, if you get any codes related to VVT or lifter problems. So if you have a problem with the VVT or you have problems with lifter, if it throws any codes related to that, shut it down, because those will destroy an engine very quickly. Again, that also has to do with timing, and that would be my number 4. Number 4 is if your timing goes bad, let's say your timing chain jumps, your engine is destroyed. And if your timing starts going weird or going wonky, you need to figure out why. If you can shut the engine down in time, what you can do is actually do a timing chain, and it'll do 90% of the diagnosis of timing problems. Because when you do a timing chain, oftentimes you're taking valve covers off. The valve covers will tell you how the cam looks. As long as your cam looks good and you replace your timing chain, oftentimes it fixes that. Now, there is a such thing as a cam position sensor and a crank position sensor. Those 2 sensors can go bad, causing you to want to shut it down. If it's making any noise whatsoever, if it's making a ticking or knocking noise, the noise is a problem. So a tick or a knock. Man, my hands are getting sloppy now. Tick or a knock noise. You hear a tick or knock, it's not good no matter what it is. No engine should ever tick or knock. Now you could have an injector pulse tick. That's different. It's not that loud. Usually when you hear those kind of loud ticks and it comes from either a lifter that's failed and it's ticking really hard, or it can come from a piston knocking, which is severely way worse. He says, I drive a 99 Chevy Silverado also. Broken speedometer, not moving after 389, which means it's got more than that for mileage on it. Oh, okay. Makes a ticking noise. All right, so now if you got a ticking noise, you're already looking at a VVT or lifter problem, and you're looking at an upper valve train problem. It could also be related to a worn out cam. Or the lifters. So that many miles, here's what I would suggest. Pull the motor and do a junkyard swap motor on it. Try to find something with fairly low miles. And when you drop it in, make sure you put new seals in the oil pan and on the rear main seal. Make sure those two are done for sure. I would even go as far as to replace all the sensors on the motor before you drop the motor in. That way you know you got a fresh motor going in. Also replace any valve covers or intake manifolds that might be cracked or has missing bolts. That's usually a wise thing to do on a junkyard replacement engine. I replaced the engine 2 times in the past. Yeah, that's the part that sucks about old trucks. I had the truck since November of 2014. So yeah, what you could do is I'll go ahead and show that one. There we go. 2024, not 2014. Sorry, my bad. I misread that. So you've only had the truck for a short period of time, less than 6 months. Oof, that's tough. So late last year. Yep. So in this case, you need to be looking at what the motors are that are going into it. And if you're going to go ahead and do a motor swap, I would honestly tell you, find a solid one and maybe do an engine rebuild on it right away. It might be your better way to go. You might have less problems with it when you do that because you can drop it in. Yeah, you could drop in a fresh motor and not have a lot of these problems because you can bypass a lot of your issues. When you do a fresh engine build, you're basically only salvaging the block and maybe the heads and the lower intake. Everything else you're going to put new on. You're even going to recondition the heads. So you're not even going to have the same heads really. My suggestion would be if you're going to go that route, find a good machine shop. Also make sure you know somebody that knows how to put motors together with proper torque specs. Because if you don't torque those engines, you're going to have a lot more problems. I see there's another question there from Jerry. I'll get to you in just a bit. Let's move on to the problem that was brought up on stanced vehicles. Okay, so somebody wants to know about stanced vehicles. Which one are you more concerned about with? The lowering or the lifting? You can stance on a lift, and I'll explain what that looks like. But I'm pretty sure you mean the lowering portion of it where you drop the car down so low that the wheels are kicked out to the side. Pretty sure that's what you're talking about. Okay, so if you're talking about a Genesis coupe, you're talking about the lower. Let me explain the upper quick, and then we'll get to the lower. All right, so the problem with upper stanced vehicles, and the reason I call them upper stance, is these are basically lifted vehicles. And what happens is as you raise the vehicle, what happens is it throws a geometry of your front suspension off. So rather than it being parallel, it does one of these. And this is what independent front suspension will look like. So if you got an independent front suspension like a Chevy pickup and you lift it up, it starts kicking the tires in, kicks the tops out and the bottoms in. And what it does is it chews up the tires. Because the only way you can fix this is you need to push your bottom out. The bottom has to get pushed out. And when you push the bottoms out, you can straighten that back up and get it aligned to where it won't chew up tires. Tire wear is the #1 problem on any stanced vehicle, lifted or lowered. So tire wear, #1. #2 is worn out suspension components. It can wear your suspension components a lot quicker. #3 is you can have body damage or wear. So this is the biggest problem with stances right here. When you get into wanting to drop a car down, you're wanting to try to push it out and get a wider stance out of the vehicle. And on a pickup, what that looks like is you're pushing your tires out here, pushing your tires way out. And as you push those tires out, not only do you wind up throwing rock chips up the side and scratching up the truck real bad, but what happens is you add a lot more bearing wear here, right? So as you have your axle here, these wider tires put a lot heavier load on the bearing. And what that can do is wear out that bearing prematurely, especially on rear-wheel drive vehicles. So that bearing wear does a lot of damage on the internals, meaning you might be rebuilding a rear axle, not too long into it. The body damage, if you're already doing a stanced vehicle and you're dropping it down, you already know what's going to happen, is the car tires are going to rub up into the wheel well, meaning they're going to do damage to the body panels right here. And what'll happen is as you kick these out, you're actually damaging suspension. So even though the tire wear is going to be the thing you're going to notice the most, there's guys with stanced vehicles where the tires are so kicked in, it looks like this going down the road. If this was the tire, it starts wearing the tire. Now everyone thinks it's going to wear right here. It's going to wear out the inside of the tire first. But what happens is it deforms the tire. So now the tire that's sitting like this is actually deforming like this. And it's pushing more of that material to this side. So it scuffs the tire here, meaning you'll see a lot of damage out here. I'm not going to do stanced vehicles, but I know people online who stream Roblox And the owner stances cars. Yeah, stanced cars, in my mind, cost you money. They might look cool at a show, but if you're not building it for a show purpose, I wouldn't do it as a daily driver. This is a bad design. You're going to go through tires. Usually you'll go through a set of tires in about there you go. That's the kind of mileage you're going to get out of your tires if you do a stance. It just destroys them, tears them up. Longer bottom control arms for the lifted, right? Yep, that's what it is. So when you're doing, Jerry, when you're doing lifts, you want longer control arms. And you have to look at your suspension setup. Not everyone runs the same suspension setup. So let's take a look at an A-frame design. So you have an A-frame on top. You have a control arm on the bottom. You have your spindle. Okay, so here's your control arm. As you lift the vehicle, these are going to drop down. So they're going to come down to give you that lift. When you do that, it actually does this. It does the same thing as when you stance a vehicle. So it's going to cause that wear out here because it's going to deform the tire like that. So you're going to get really bad tire wear. How would you correct this? Because when this drops down, it's going like this because that top arm, this one, is not long enough. It's going like this. It's dropping down and away, meaning you'll need a longer control arm if you're going to do that lift on the top, not the bottom. Let's look at it from the other direction. Let's look at it from a solid axle setup. That's going to be a little different because now you have a solid axle setup, meaning a solid axle here. And you've got your spindle here and here. And then you have your control arms. So you might have a control arm that goes back to the top, back to the bottom. Same on this side, back to the bottom, back to the top. Let me do a side view for you. So here's your spindle. There's your axle. You have a control arm going back this way, a control arm going back this way. When you lift this, what happens is it rotates it down, meaning that it's going to rotate the axle like that. What that does is it throws the axle forward and can do damage, especially on four-wheel drive setups, to that drive shaft that goes to your differential. That shaft takes a lot of abuse when you lift it because it's not, if it doesn't have enough to extend, you run into problems. But yes, whenever you do a lift on a truck, you want the longer control arms on the top. And that's only because you're trying to true this measurement up here. You're trying to true it up so it looks correct. Okay? You're trying to true that up. Well, you can't make that true and straight if you don't lengthen it. Because as you lift the vehicle, your mounting points here don't change. If you don't change the length of your arm, what'll happen is you bring this down and the whole suspension just kind of sags away, because that is not long enough to extend straight down. And the reason I know that is my brother had a truck that he did, that he had a 3-inch lift on it, and he had to get special upper control arms because he had an extra 3-inch lift in it. So that's how that happened. All right, guys, we've been going for quite a while here. If you guys got any other topics you guys want me to cover, otherwise I think we might go ahead and break into this throttle body and see what's wrong with it. I was talking about taking the cover off, but there's no point in me taking the cover off the top. What are the disadvantages of owning an old BMW? cost of maintenance and repair is the biggest one. Old BMWs, you're going to run into, obviously maintenance is number one on anything BMW related maintenance. If the maintenance hasn't been done, you can run into a whole host of problems. Motor problems, transmission problems, anything. Maintenance is super, super picky on them. You can't miss the maintenance. Messing up and missing the maintenance deadlines can cost you big, 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 big money. We're talking motors and transmissions. So maintenance, number one on any older one. If it doesn't come with maintenance records, I probably wouldn't buy it, especially a BMW. Next, you're going to be running into a potential of motor problems. Some of those had motor issues back then. And some of that was due to the things that they were fighting to try to change with Europe and how they were trying to mimic some of the emission laws back then for GM and the US, Ford, Dodge. They were trying to play around with that and they were trying to be better. Well, in the process, they made some of their motors were junk. They were not very strong motors. And obviously the big one that most people miss for BMWs is suspension issues. So because suspensions are so problematic on old vehicles, if you don't replace your struts and all that stuff when you're supposed to, if you don't keep an eye on your control arms, you run into a lot of problems. He dropped some more info here. True, I had a BMW M5 series 2 weeks and only put 6K on it until I sold it. It has 29K miles, then I sold it, it had 36 miles. Yeah, so these are all big things on the BMW. The maintenance is huge. You can't miss maintenance. They definitely have motor problems. There's a whole host of motor problems they can have. And then obviously suspension problems are always plaguing them because they're always pushing the envelope on their suspension stuff to try to beat the next company out there. They want to be known more for handling than what they do for horsepower. The problem is when they play around with horsepower, I don't think they don't have enough research and development in it to do it right without wrecking stuff. They try to put the money and research into it, but when it comes down to it, they still have to make it affordable to sell the car, and that cost comes at a price. All right, guys, we're going to transition over here. So I'm not going to give you guys the breakdown on the car because you guys can look back at other videos and see kind of what we've done with this already and where we're at. We're probably going to do wheel liners next week. I promised you guys a story on tuning. Sorry I'm taking so long to get to this point, but let's do this. While we're doing this, I'm going to play around with this. This is where our motor is, and this is where our throttle position sensor is. So while I'm giving you guys that story, I'm going to work at picking this board off of here. So, back in the day, I had an 86 Mustang GT. And it was the hatchback style. Fun car. I put a motor in it that a friend of mine had built. And the motor was pretty good, not too bad. And that motor, was pretty stout. Had a decent cam in it, had an E-cam if you guys know anything about cams. And the E-cam was computer related, meaning that it was designed to work with a stock computer. So we put it in there, we got everything tuned, got everything right on it. And here was the issue. My stock injectors, which were gray, were not substantial enough for the cam that I put in. So I did the math and I figured out what injector size I needed. Once I figured out the injector size, the rest was a cakewalk. So once I knew the injector size, which were 24-pound injectors, which were blue, I put those in and I went to adjust my timing. I got my timing set really close to stock, but I decided to check one more thing before I got carried away. My throttle position. Once I checked my throttle position, I realized my throttle position sensor wasn't working the way it was supposed to. So I had to take it out. I had to fix it, get it dialed in. Once I got all that done, I was able to set timing. We took it to the dyno, and the only thing they had to adjust was the fuel pressure regulator. That's it. Again, that was on an 86 Mustang GT, fuel injected. And that car I had built from the ground up. The only thing I didn't do was the transmission, which I needed to do if I was going to continue driving it. So we're in the process of wiggling this cover off. I want to make sure there's no other bolts in here before I just stick a flat screwdriver in here and pry it off. So when I undid this, I felt some pieces fall out of here already, guys. Let's see. Jerry, the Olds 22R, best motor I had. Or the old 22R, yeah. I don't know a lot about the foreign motors, guys. Honestly, I haven't spent a lot of time in those. But I can tell you that foreign cars come with their own set of problems, and everyone who does them tends to work on them. And when they work on them, they usually have a set of stuff that they do. There's specialty tools for a lot of those guys also. Boy, it's a good thing I didn't buy this motor. This doesn't come off of here. The cap is actually fixed to this through this right here. There's a gear set in here. Right here, it's plastic welded in. I'm going to have to snap this off. But yeah, anytime that guys are dealing with the foreign motor setups, you guys have to rely on a lot of the stuff from the country that it was built. And sometimes that is difficult when you live in the U.S. Yep. This is why we buy whole throttle bodies and not just fix these motors. They don't come apart. At this point, I'm just breaking it just to get in there. Just so we can see what might have failed and what didn't. So I'm seeing where the power comes in for the motor. So we have two connectors right here. On the back side right here, this comes from this connector here. These wires are fed in right here, down to here. This metal sprocket is your motor. That's the electric motor that moves this, which makes sense because this would be your motor right here. Right there. That's what was holding this on. Plastic welded down onto it. See? Right down into there. Okay, so you might be asking, why did I take this apart? Because I wanted to show you guys just how delicate and sensitive this trash is. These are plastic, meaning that this metal gear could shave this plastic gear down pretty quickly if for some reason it got hooked. Plus this is a plastic gear on top of this being a plastic gear for the blade, meaning that if a bearing goes bad in here, what can happen is this gear will actually start chipping teeth off on this gear, meaning that when you give it gas, it doesn't respond because it's not able to actually move this because it's skipping over the teeth. Also, if it catches, what will happen is it'll throw another code, usually related to throttle position being out of whack. So it's kind of hard to see, guys, but down inside here, this is where the big spring lives that controls the blade. And where the bearings usually have issues is right here. So if you're cleaning out your throttle body, remember how I said always hold it up like this so you don't get that liquid up in here and short out that circuit board? If debris gets down in here into this bearing, you run into more issues in the bearing because the bearing can start going bad and cause sticking. Don't know if you guys could hear that, but that bearing is sticking when I press the blade. That's what was causing my idle issues. We can also verify the manufacturer of this one. It's stamped right on that gear. Try to get into a spot that you guys can see it. But so this is a Bosch part. So there you go. There's the internals. This is a Bosch part. It's what I put in. I went with OEM, so I did not have any issues. The reason why is because these handle a lot of your idle functions. When your idle starts going haywire, it's better to replace these as a whole unit. Don't just try to replace this or the motor down inside there. As you guys saw, this cover, it's a pain to get off. And all of your circuits and everything that's important is in here. So when this was on here, so this was jammed into the board. There's a board inside here. That circuit board is where your throttle position is. And it's connected right here on this blade. This is exactly what we were talking about today. Exactly the problem that we were having. Oh, got a few to get caught up on here. Jay, the 8th gen Camry 4-cylinder is the best motor I have currently. Yeah, the Camry is pretty decent. They built it to last. Camry really didn't have a whole lot of massive recalls. There were some other stuff that's happened that they've had issues with. But yeah, the only thing that had that kind of plagued the Toyota camp recently was motor issues related to their was it the ton or was it I think it was the Tacoma had a motor issue. The big massive recall on the Toyota motors. They had a massive recall on them. They were just finding metal shavings in it from not being built right from the manufacturer. So that's one of the big things from the Toyota camp that's happened. Jay, again, because I have a 2024 XLE, I got probably around 1 to 2, like 1 to 3 weeks ago. Okay. So yeah, you've got a fairly new car. Just make sure you do the break-in on it. Make sure you get the oil change. Don't ever go past 5,000 miles on an oil change. Guys, I can tell you that is the worst thing to do to your car, is not doing regular oil changes. The way the manufacturers have them set up, they're actually causing people to have to replace engines. So change your oil every 4,000 to 5,000 miles. 5,000 being max. Don't ever go past that. Especially if you're running full synthetic. If you're running conventional, don't go past 3. It'll destroy your engine really quick. My Sopa said, I like Bosch. Yeah, Bosch is a good company when it comes to building a lot of this stuff. And honestly, it's kind of the company that a lot of the manufacturers have went with as well. When you take things apart, this, in all intents and purposes, is OEM, because it even says General Motors company right on here. But when you pop this open and you look at the drive gear for the pulley, for the main blade, it says Bosch. This is a Bosch part. It's a Bosch part with a GM cover. And that's kind of what I wanted to see. And I wanted to see where the sensor was for the throttle position. And it's right in here. It's in here. That's why I had such a problem getting it off. Jay, my dad has a service vehicle maintenance light on his 2018 XSE Camry. He says he can drive it for another 1,000 miles. Do you think it's a good decision or no? First thing I would tell him, check all your fluids. If he's doing this because he needs to build up some money to take it in and get it fixed, check all your fluids. Make sure your fluids are running good, and make sure the car isn't falling underneath one of the things that I warned you guys about. If it's misfiring or not running right or stuttering, if it's jerking and it doesn't want to run right, then don't drive it. Number 2, listen for the noises. Make sure there's no popping, pinging, or any noises like that. Yeah, tell him to check those fluids, because if the fluids are not full and they don't look right, let's say he pulls the dipstick on the oil and it's shiny, that means there's motor damage. Don't drive it. If it's something related to oil consumption, he might be low on oil. So gotta check those fluids. Guys, that's number 1. Whenever we do anything maintenance, we always check fluids. I do it every week in every single vehicle I got. You just don't know. You could get a slow leak somewhere, and next thing you know, you're a full quart low or even more than that. So fluid checks regularly, guys. I heard a squeaking noise from probably his left or right front rim. That's going to be suspension or wheel bearing issues, or possibly brakes. You're going to get a lot of squeaking noise coming from a brake, especially if there's brake dust built up on it. You're also going to have issues with things kind of wearing out. CV axles can squeak if they dry up. So those are all things to look at. Usually a CV axle will have a torn boot and there'll be grease everywhere. That's usually a good sign that the CV axle has gone bad. Brakes, you can usually look through the rim. Let's see if the rotor's grooved. If the rotor's all grooved up, you need to do brakes on it. Also check the pad wear. Make sure you have quite a bit of pad left on it. Do that by just pulling the wheel, looking down from the top of the caliper. There's usually inspection holes. Look down in there and make sure there's enough pad left on the inside and the outside of those pads that sit against the rotor. That's usually what that squeak would be from. He scraped his rim again or against a curb a month or two ago. So what he could have is a bad wheel bearing issue, to be honest with you. Because what could have happened was when he scraped that curb, it could have pushed the rim over like this and caused that wheel bearing to suffer damage from being scraped against that. So again, I would have that checked. You can check a wheel bearing pretty easy by jacking up the vehicle and pushing the tire in and out like this, or in and out like this. In and out like this could tell you a tie rod end. In and out like this can tell you a ball joint or a wheel bearing. I had it also on a bent dust cover. Yep, it'll do it on a bent dust cover, same thing. But yeah, always look at that, look inside there, see what's going on with that. So guys, we're approaching the 3-hour mark. Guys, this has been a great live. We do have some topics coming up. Next week, I'm going to be getting the wheel liners put in Malibu steel back there. That's our 2012 Malibu LT. That thing suffered a deer hit, and the bumper's here. All the pieces are here, and we got to get it put together. So that's going to be kind of the focus next week. We're going to dig in. We're going to get the wheel liner put in it. We're going to start getting things ready to put back together. I need to get new tires because the tires are bad. We're going to put new tires on, so that'll be another video we got coming for you guys. Also, we had some thumbs up on me breaking down the Cash for Clunkers scam. So I have a situation where I will probably do that one while I'm on the road. I have something coming up in a few weeks that I might be on the road, and I'm going to do that one then. And I'm going to break down the Cash for Clunkers. We're going to get into it. We're going to dive into that. If I can't do anything that weekend, then I'm going to push it, and I'll do it the next weekend. So in 2 weeks, we may or may not have a video, but I will work out those details and get back to you guys on that. But for the most part, that's what we're looking at. We want to keep plugging away at this thing. We got it running right finally. I need to make sure I can get this thing put back together now, get the front bumper on it, get all the components put on it. We do have some work in the back, so we're not done, but we want to get the front mostly done. We've already done brakes on this thing a while ago. We just got done doing struts not too long ago. We did the timing chain and got all that straightened out. And what's left now that we fixed our engine code, is to get our front bumper on. So that's what we're really going to focus on over the next probably week, see how far we can get and go from there. We got one more here from Jay. He was excited. He was exiting out and he turned right and then hit the curb on accident because he turned right too much on accident. Yeah, so what I would assume with that deal is that when he hit that curb, it actually pushed everything on the bottom side in, and he could have a bad wheel bearing, a bad ball joint, he could have bent lower control arms. All of that stuff needs to be looked at, especially if it did damage to the rim. If he scuffed and scraped the rim, he did hit pretty hard. So I would look at the rim, make sure the rim is in good shape. If all of that looks solid, then I would just go ahead and do what you got to do to get it put back together. You're on every Saturday, right? Yes, Jerry, I am on every Saturday at 1 p.m. Central with a new topic. If I can't go live that day for some reason, I usually do post. That's why I tell you guys, make sure you guys subscribe, because if you guys subscribe, you'll get my posts as well, so that you'll get notified if something happens. Also, ring that notification bell so you guys get notified when I go live. Those things really do help. Again, always the likes help so much because it helps push out content. It helps the channel grow. We're really trying to grow this year. I would love to bring you guys merch, but we got to get more engagement going before I can really invest in a merch store. So we are looking at doing that as well. Jay, I had told him to replace the rim and put a steel onto it, but he said it was fine. I would actually have that rim checked if he hit that curb hard enough. I would have it checked. Take it to a tire shop, have them spin balance it, and tell them to watch the rim. If the rim starts going like this, the rim is bent. If they spin balance it and it stays like this and the weight doesn't get ridiculous on it, then he was all right. But if they have to start pumping a bunch of weight on it and it's starting to wobble inside the tire balancer, then he's got to get a new rim. You can go with the aluminum rim if you can find a used one that's halfway decently priced. You can just swap out a rim with a junkyard one, or, you know, an aftermarket setup if you want to go with all four. But have them check that rim for sure and have the bottom suspension checked. When you hit a curb hard, you need to check your suspension, because if something breaks loose, it can really be catastrophic. It can really hurt you. Yeah, Jerry, yep, every Saturday we do this. New topic every week. So next week, we're going to be digging into our project here on Malibu steel. We got wheel liners to put in. I need to get that whole right side put back together. We're probably going to start assembling the bumper next week as well, too, so I can start getting that bumper put on that car. He didn't check the bottom suspension. Got to check it. The bottom suspension is where all the damage would have happened, because when he hit the curb, it's the bottom side that took the hit, not the top. Because it basically, when it hits, it's going to hit and push everything this way. It's going to fold it under. So you got to check the bottom. The top might have survived because it folded in towards the bottom. Thank you very much, Jerry, for the subscribe. Awesome, awesome. I like giving guys a shout out when they chat in. You guys have been awesome. I've loved the chat engagement today. Today was a really big topic. I got into tuning. I got into performance. I got into engine diagnostics. This has been a huge video. It was really, really important, guys, for me to tell you how I got to the point that this was my problem. That it was my throttle position sensor that went bad in that car. And that even though we put a map sensor in it, the map sensor wasn't the problem. The map was just pointing us that there was a problem. So that's why don't just chase codes. The only reason we put that in there is because I didn't have a strong enough scanner to actually diagnose the map sensor to make sure it was reading right. With a powerful scan tool, I could have saw that, and I could have saved myself the $60 of buying this. This is the map sensor. This is a brand new one that I'm not using because it wasn't what was wrong. I put the old one back in it, and it seemed to run a little bit better, but it wasn't what the problem was. The problem was this: throttle position. He didn't check the bottom suspension without having a second thought. Yeah, he's got to check that suspension, man. And then he made a scratch to the front bottom left corner of the bumper. Yeah, he hit. Which I don't know what day, what time did it come from. Well, see, that's the thing. If the scratch is on the same side as where he hit the curb, he could have very well, if the car sat low enough, he could have scraped the lower bumper on the curb as well. So that's all part of it. I know this car with the bumper on it, it sits low enough that if I caught a curb with it, I could probably catch my lower bumper. I definitely can catch it up front to where I could tear up all my front pieces, because yeah, I've come up to bumpers where I've scraped in the bottom on the front and scraped some of the paint off. So if he got scrapes down there, that was probably from when he hit the curb and he just steered into it too hard. And yeah, I'd be checking suspension before I drove it too much farther. Make sure nothing's bent, broken, or looks weird. It should look exactly like the other side of the car, only somewhat reversed, because your left and your right side are going to look very similar. It's just the positionings are going to be a little different because it's left versus right. But the components should look the same. So if you look at one side and the control arm is straight, and you look at the other side and the control arm is bent, then you know you have a problem. It's kind of, I use it as a technique. This is an old school technique, guys. Compare your left to your right, and if it's wrong, you know what you got to do. That's what you do, is you try to compare the components that you have and see how they look versus the other side, As long as everything looks and jives right, you can somewhat get by, but I would definitely take the rim in and have it checked. Have them put it on a balancing machine to make sure it doesn't wobble. Last 2 years ago, he replaced the taillight and the rear bumper. Oof. Sounds like he's been having some accidents. Oh, all right, guys. This has been a great live. It's been awesome having you guys in here. We're going to do this again next week. I've already told you guys the topic. And I'll also work on the Cash for Clunkers video for you guys. And that scam that was created by a president did a whole lot of other things we are not happy with in the automotive industry. Now, might they get reversed? I doubt it. Unfortunately, we're going to be stuck dealing with some of these problems for the future. But today, you guys got to see a breakdown of the entire computer system related to throttle body, throttle pedal, and 2 massive sensors that have everything to do with that system. So thank you guys for all the support. Continue hitting the like button, the subscribe button, ring that notification bell so you get notified when we go live, which we do this every Saturday at 1 p.m. Central. Thank you, and I'll see you guys on the next one.